We've taken our data all the way from the YouTube API into our persistent staging area. And we also have an idea now of what we want our target dimensional model to look like. It's now time to build that target dimensional model as well as a Power BI report that uses our model as a source. Okay, so before we get into the actual development, I want to talk a minute here about the very simple dimensional model that we're going to be using to fulfill the requirements. So let's jump over here to a conceptual model. This is a very basic model, so we'll just take a second here to go over it. First of all, we have basically two granularities of data that we're dealing with. So I'll start with the channel side of this conceptual model. We have four different fact tables that we want to create, and that's the in-screen, card, annotation, and basic channel fact tables. And each of those are at the video, date, plus several degenerates grain. So what we're going to do is we're going to go ahead and take that data in at its atomic grain and load some fact tables with it. And on the other side, we have our playlist, which is basically the exact same thing. It's a playlist basic fact table. The only difference is that now we add the additional foreign key to our playlist dimension, which we've already created. Now, once we have those first atomic fact tables created, we could go ahead and use that as our ongoing source for this model. But to simplify things a little bit, we're going to go ahead and create a couple of aggregate fact tables. We're going to create two. One is going to be a channel day. So every record in that fact table will represent a single video day worth of measures. And the other will be a playlist day. And of course, on that side, we'll have every record representing a video playlist day grain. So basically, it just gets rid of the degenerates part of the grain of our atomic fact tables. And on the channel fact side, we're adding width to our aggregate fact table as opposed to having a number of different fact tables, one for each in-screen, annotation, and cards. All right, let's make it happen. Okay, so I'm over in my LeapFrogBI project, and I'm looking at my dimensions now. I can see that I already have 4 dimensions created. I'm actually not going to use that channel dimension. I've created, I'm going to leave it in place, but I'm not going to set a foreign key to the channel because once again, the data I'm using, it only has one channel, and there's no real reason for me to have a foreign key to channel because I know it's the channel that I want to be analyzing here. But in your case, if you have a different scenario where you're trying to analyze a number of different channels, then of course you would want to add a foreign key to channel. I am not going to do so. All right, so to make this happen, I'm going to go over to the new pattern area. And once again, I already have all the data in PSA. That's what we used to do our initial discovery on. We wrote queries directly on PSA. Now I need to get that data into the fact tables that we just discussed. So to do that, I'm going to go down to let me scroll here, to a fact design pattern, and I have 2 to choose from. Now, these 2 patterns are basically identical. The only difference is one of them starts using a source, which is a stage table, and the other uses a source that is a PSA component. So obviously, I'm going to be using the PSA component. So I'll select this one here. And briefly, what this design pattern does is it takes the data from whichever source, in this case, a PSA source, and then it handles load status tracking. So it's tracking whether the records in PSA have been processed into the target fact table or not. And that's what the first transformation does, is it selects the unprocessed records out of PSA, making them available downstream. The next transformation here, the fact grain, that's what's going to ensure our data is at the right granularity to load to the fact table. And then finally, we load the data into the fact table. And if all of that succeeds, then we'll come back and we'll mark those records as having been processed in PSA. So it's just a basic design pattern. Oftentimes you'll need to go in and add some business logic to this pattern, but in my case, this is a very simple situation. The pattern is going to pretty much do everything for me. So let me go ahead and fill this out. I'll start with channel basic. And I'm going to take most of the default values here. For the load status tracking, the unique field ID by default will be called GUID. I'll take that. The load status field name by default will be FLS for fact load status underscore followed by the fact table name, which I'll put down here. I'm going to call this YouTube channel basic. Next, we have our FS component name. I'll take this default there again. FS is fact source underscore fact name, so it'll be FS underscore YouTube channel basic. What connection do I want to use for my FS component? That will be my transformation. And then the FULS component name, that's another component. And again, I'll stick with the default. Fact update load status is what FULS stands for. Same thing here on grain. FG is fact grain. I'll take the default name. And for the location, I'm going to put that in my transformation defined connection or area of my target. Let me scroll down here a bit. Oop, jumping around here. There we go. Okay, so I've already filled out the name of the fact table. It's going to be YT for YouTube underscore channel basic. And then my destination is going to be my DW connection. In this case, I am not going to establish a foreign key to channel once again. So I'm just going to check date and video. And then I need to designate a few things down here in this pattern. I don't know why it keeps jumping on me like that. There we go. So first of all, I need to define the granularity. So the granularity of this pattern is the date. I'll go ahead and select the channel, the video, live and on demand. I'm going to treat that as a degenerate. There won't be a foreign key set to it, and I'm not going to create a live or on demand dimension. So just for this atomic fact table, I'm going to go ahead and set that as a degenerate. Same thing for subscribe status and country code. Now, of course, if you wanted to have a location dimension and you had different requirements from me, then you would want to go ahead and handle that as a foreign key and not a degenerate. What do I want to include? I'll include view count, comment count, like count, dislike count, share count, watch time, and a lot of these other things here I really don't need, such as card clicks, because I have another fact table that gives me the information I need for cards. So I'm not going to include that. Let's see here. Annotation closes I don't need. Annotation clicks I don't need, because again, those things are going to be in the annotation fact table. So I think that's all I need here. I'll go ahead and generate that pattern. Okay, so we got our pattern generated, and I've just jumped back over to the source of the pattern, which once again was a PSA component in this case. So you can see everything downstream of the yellow highlighted PSA component is what the pattern generated for me. Now, I've also gone in and completed the foreign key lookup, so I'll show you what I did there. So I'll just jump on, I'll click on the fact table here. I can see that I have 2 foreign keys assigned, one to video and one to date. So let me go to component details so we can take a look at those on clauses. Okay, so for our foreign key to date, we'll take a closer look at that. I created an on clause, which is simply the full date coming from my date dimension matched up to the date coming out of the source, and I'm just converting that to a string. That's pretty much it. Let's see, let's take a look at video. On the video, I'm taking the object ID, which is the natural key of the video dimension, and matching that up with the video ID field coming out of my source for this fact table. So that's pretty much it. We create those two foreign key on clauses. The pattern did all of the rest for us. So all I need to do now is just repeat this process for the other portions of the atomic fact table. So I'll pull those up now. Here we go. So we just created one of these 5 atomic level fact tables. I'm going to go ahead and create the rest of them, and then we'll come back and show you what we have. Okay, so I went ahead and created the rest of the fact tables, that the atomic level fact tables, and I've also went ahead and created the aggregate fact tables just to speed this up a bit, and I'll show you how I did that. I'm going to jump over to the deployed target model here, and if I just refresh my table list, you can see here that we have each of the fact tables that we're talking about. We have channel annotation, channel basic, channel card, and then channel day is our aggregate fact table. Channel end screen is atomic, playlist basic is atomic, and playlist day is an aggregate. So the one we were working on before I went and completed this was basic, channel basic. So if we look at this, we can see that we have our channel ID, video ID, live or on demand, and subscriber status, country code. So all of these things are the degenerates that were part of that source data. I'm treating them as degenerates because I'm not going to go and create a dimension for these things because I just have no need for them. I'm just creating this atomic level fact table, which I fully never expect to access directly. I'm loading it in this way so that I can keep my initial load of a fact table at the atomic grain. Then we have two foreign keys here, one to date and one to video. All of the rest of these are measures that were included in this fact table. The same thing is true for each of these. So I'll just take a look at another one. Here's channel annotation, same situation here. I have a foreign key to date, foreign key to video, all of my degenerates are here, and then I have a set of measures. Okay, so once I got all that done for my initial 5 atomic level fact tables, I then just came in and created a query manually. I wrote a SQL statement that would aggregate that data to the granularity that I wanted. So let me just show you what that looks like. And when I say aggregate, I'm aggregating so that I can create a source for my aggregate fact tables. Let's take a look at that. So channel day, for example, both of these are the same, but channel day is a little bit more complicated, so I'll just show that one. Not real complicated, but a little bit more than playlist. I'll copy this SQL out so we can see it a little better over in Management Studio. Okay, so let me hide there we go. So what we're doing is we're taking each of the different sources here, starting with channel basic and going left from there. So channel basic, we know, has a record for every video for every day. And there's no way that we're going to have a record for a day in channel annotation, for example, if it's not in channel basic, because channel basic is the views. If there's no view, there's not going to be any annotation. Same is true for cards and end screens. And that's why I'm starting with channel basic as my foundation for this query. And you know, we just are rolling the data up, so we're grouping the data by the grains that we want. Then we're creating a left join here. I'm going to scroll down a little bit. We're left joining to the annotation, then we're left joining to the card, and finally left joining to the element. Now, there's a couple things in here that are important, such as these filters you see. There's only certain types of in-screen element types that I'm interested in. And you can see what I have here. I have associated website and associated filters for the element type numbers. You really have to go take a look at the API documentation and make sure that you're including the information that you want, because I mean, obviously you want to include in your fact table data that represents your requirements. I'm not interested in all types of cards, for example. I only want to know cards that are actually links to my website. That was what I wanted to have. So I'm limiting my cards to only those types of cards. The same is true for annotations and end screens. So be sure you take a close look at that before you just throw everything into your fact table. Okay, so once I have this in place, I just created another component. I'm not going to show all of that here, but basically I just go into transformation, new component, and I'm using an existing transformation, which basically means that this component accepts a SQL statement as its source, or a profile, I should say more accurately, and that profile contains a SQL statement. And you can see there's no upstream lineage from here. This is simply selecting from those atomic level fact tables, rolling the data up and structuring it the way I want so I can load it into my aggregate fact table. And that's what I did next. If I just click on this aggregate fact table here, it'll jump me over to the aggregate fact table where I can see that now I'm at the video date grain for this fact table. And if I scroll down, I know there's no degenerates here because nullable is set to true. And if I had a degenerate dimension in this fact table, it would say nullable false. And now all the measures that I had in each of those individual atomic fact tables, the ones that I was interested in, they're all now adding width to this aggregate fact table. And all of this is just being done to simplify the navigation of this little simple model. Okay, the same exact thing was done for YouTube playlist. It was actually simpler because I was only sourcing data from one atomic fact table. All I really had to do here was to get the data up above the degenerate grain. So I just needed to have it at the playlist channel, playlist video date grain. You may include channel or you might not. In my case, it didn't matter because I only have one channel. And once again, I selected the wrong one. I selected playlist basic. Let's go to playlist day. Playlist basic is the atomic playlist fact table. Now this is going to be the aggregate playlist fact table. And no degenerates, only three measures here: views, watch time minutes, and playlist starts. That's it. Okay, so once I have all this project updated, all I did was go over to the deploy page. I queued a build. Click on make current. A build will be queued. I downloaded the build, ran the deploy package, and then began the load process. And now I have my target model in place. So if I look at playlist day, for example, it's a very simple fact table. All I have is a foreign key to date, foreign key to playlist, foreign key to video, and 3 measures. If I look at channel day, all I have is a foreign key to video and date, and then I have a number of different measures. It's just that simple. So those 2 fact tables combined with the dimensions that we had already created, those fulfill all the requirements that I have for my YouTube analytics that I want to put into Power BI. Now it's time to go over to Power BI and build a report, or maybe a set of reports on top of this model. So let's make that happen. Okay, to start with, let me just go over to the model section here in Power BI Desktop so you can see what this simple model looks like. Again, I only have 2 fact tables. It's the far right and far left table you see here. And I have 3 dimensions: date, video, and playlist. So my fact playlist day, again, is at the date, video, playlist grain. And my channel day fact table is at the date, video grain. That's really all there is to it. That's why we did all this work to make this very simple. I didn't do a whole lot as far as adding or augmenting values or attributes to these different objects at this point. I did one thing. I added this year, week, and year, month again, just because I like having those available for reporting. All right, now let's look at the reports that we created. So here we go. If I take this this report, once again, if you remember, we talked about the requirements. I'm interested in understanding branding, audience engagements, and click-throughs. And of course, I need to also be able to understand whether my data is current. How current is the data? So that's what these different pages are. Now, I'll tell you what I'm going to do. Instead of looking at this in Power BI Desktop, which is where I developed all this, I'm going to move over to the online version of this report. Okay, so here we are. We're now on the online version of this report that's been deployed. I want to point out a couple of things here before I move on. First of all, the server that I'm using to do all this processing is an Azure VM. And I have automation set up on that server so that it turns on and off at the times that I want it to do so. And so basically I have it set for this project to turn on once a week on Monday morning, very early. And when it turns on, the ETL process is also scheduled to run. So the server automatically turns on, the ETL process runs, and at the end of the ETL process, I have a step that actually shuts that server down for me. Now, before it shuts down, I have a little window of time in there, and during that window of time, Power BI is scheduled to refresh. So I have a gateway on my Azure server, and the scheduled refresh here in Power BI is set such that it can access my server and refresh the data again early on Monday morning and refresh this report. So that's how some of the logistics are happening here. Excuse me. So you can see I have a few reports here. The one our final report here is called YouTube Day, and I'm going to start by going over to the data validation tab or page. So on this page, this is where I can get an understanding of how current my data is, one, and I can also understand if there are any missing bits of data in the data set that I'm accessing. So on the left side, that's just my channel validation. On the right side is the playlist validation. So if I look at this top left chart here, I can see that number one, I'm missing a couple of weeks. So this is a weekly bar chart, and I can see that on the 5th week, I only have 6 days of data in that week. I don't have a 2017 6 or 7 week. I'm missing those weeks entirely. And on 2017 8th week, I only have 4 days. So what's happening is, as this process continues to run each week, it's going out and getting any reports that YouTube has generated for me. I have no control of when those reports are being generated. I do hope that this little gap gets filled in. I'm pretty sure it will, because in March timeframe, there was also a pretty good gap, and I've seen that fill in. So I'm pretty hopeful that this little February gap will get filled in. If not, it's not the end of the world for me. I'm more concerned with current data, frankly, but it really would be nice to have this data be complete. So I'll keep an eye on this as I'm using the report to, again, make sure I understand how current this information is. Okay, so now I'm going to jump over to the branding page. Now, the requirement I'm trying to fulfill here is just to understand how often the YouTube brand is getting in front of somebody. So let's just take a look at one of these reports. I'm going to click on the edit button here just so we can show how this was created. If I select this top left chart here, I can see that I'm looking at the data by week right now, and I'm showing a view count. And if I look at my filters, I have no filters really in place. So this is a weekly count of views for all videos on my channel. Now, if I turn on visual interaction, I can see how that is going to impact other portions of this report. Kind of got it overlaid here with this little text area here. So let me see if I can move that up. I'll just squish it down for now. I won't save this. Okay, so let me select this. So I can see that when I make a selection in my chart that I have highlighted right now on the top left, it's going to actually filter the chart on the right, which is a particular video count. So let me just do this so you can see the behavior. I'm going to turn visual interaction off. I'm going to go into reading view. I'm not going to save changes. Okay, so here's the behavior. If I click on, let's say, the current week, what happens is it filters this chart to the right, and such that I can see which of my videos was viewed the most. And then I've got a list of video views in descending order. So I can see that my video that's called Facts and Dimensions received 491 views. And last week, that was actually the most popular video on my channel. And of course, I can just keep going down the list. Now, the same is true down here for playlist. Which of my playlists are the most popular? Well, I can see that last week, the dimensional modeling playlist was by and large the most popular playlist. It's been that way for a while. Maybe I'll be able to compete with that with this particular series of videos. I don't know. But that's a real broad topic, dimensional modeling. So a lot of people are interested in that, where this particular video series on YouTube Analytics and Power BI may not have quite as broad appeal, but we'll see. We'll see how it does. In any case, this is how I determine how well I'm doing with branding. Am I increasing my brand exposure or not? So let's go over to audience now. For audience, there's not a lot here that I'll click on edit report so you can see how I source this. There's not a lot of information here. The only thing I really had to go on was subscriptions. So, you know, an audience you could say is the number of viewers, but I really wanted a discrete count of individuals and viewers. You know, a person could view multiple times, and it also could be just someone that just viewed for a second and left. I wanted to consider the audience something a little more substantial. So for that, I'm using subscriber gain and loss. So all the green bars here show me on a weekly basis what my subscriber gain count was, and the darker, I guess that's a green dark color, is my loss per week. And I'm not doing any filtering here. This is just simply number of gains and losses per week. Now, I do have this set up to drill across time, so I can go up and I'll be at the monthly gain here. So now I can see how many subscribers did I gain on a given month. Of course, knowing that the current month is not complete, I wouldn't expect that to trend well with historical months. And I can really see now that in February I have some data loss because you know, that's why the number is much lower than the adjacent months. So that gives me an idea of how I'm doing with growing my audience. Now I'm going to jump over to engagement. Engagement is set up a lot like branding. This is you know, if I select the current week of engagement, I can see which of my videos solicited the most engagement, just ranked in descending order. I can see which types of engagement those videos had. So for example, down here, I can see bus architecture had 2 likes and 3 shares, totaling a total of 5 on the engagement. Eventually, I might get a little more sophisticated about how we score these things, but for now, I'm just getting familiar with the data, and this is plenty fine for my little channel. This tells me what I want to know. You know, our goal here is to increase engagement. We're really interested in engagement because this is all about inbound marketing. We want to put content out there that's appealing enough for people to engage. We really want people to comment and share and tell us what you like and don't like. So I hope you all will leave us a note. Okay, next is click-throughs. This is how we want to try to gauge the, I guess, more direct result of a video. How often is a video soliciting a click-through to our website? That's what we're trying to understand here. And it's set up the same way. If I click on a week, I can filter out the videos and figure out which ones solicit the most click-throughs to our website. And then down below, I can see which element actually solicited that click-through. And right now, everything for last week was, in-screen elements. If I look at the prior week, week 17, everything was based on annotation clicks. If I look at the prior week from that, we've had some card clicks and some in-screen elements. So we don't, you know, in-screens are still pretty new. They're new to us at least, and we're trying to understand how to use that feature in YouTube. What's the best way to do that? We've got our outros on our videos kind of structured where we can begin to experiment with the different types of in-screens. But it looks like that's the direction that YouTube is going, so we're just trying to understand how to best use them. And this type of report will help us understand if we're being successful or not in whatever decision we make when using those in-screens. Okay. Well, look, for those of you that stuck with me through this video series, I just want to first say thank you very much. I know this does take a bit of time to follow along, and I hope that you maybe learned something. I know I did along the way. Accessing all the way from accessing the YouTube API, which took me a bit of time to work my way through the I don't know, nuances of that. Moving into our initial data collection in LeapFrogBI, doing the data discovery, and then finally creating our conceptual model and getting our target dimensional model in place. And now we're at a point where we have a refreshed every week report in Power BI that I can easily keep tabs on, that I can easily use to keep tabs on how our YouTube channel is actually doing. And although I haven't done it quite yet, I have a lot of more plans about how to use this information and integrate it with other bits of information. Specifically, I really want to understand how this works in sync when you look at it in correlation with the Google Analytics type data. So look for that type of information to come in future videos. But for now, I'm going to sign off. Again, thank you very much for following along. Don't forget to leave us a comment. We really want to hear what you have to say. If you found this information useful, that we're flattered to hear you say that. If you didn't like something, we want to hear that as well. And of course, if you can use some help getting your YouTube analytics data into Power BI or creating a dimensional model, or if we can help in any way with your BI or data warehousing needs, feel free to contact us at support@leapfrogbi.com, or just go over to leapfrogbi.com and check out our website.